Hey guys, Mr. McKinney here, just going through a review of Unit 6, which we did before the break, but it will be covered on the Unit 7 exam as well. Unit 6 and 7 are both all about integrals, but we introduced them a little bit differently in Unit 6, so we're going to go over those topics real quick. An antiderivative or an integral just undoes what the derivative does, and then this first piece is just about notation. So if we take the integral of little f of x dx, you get capital F of x plus c. And then same thing for f prime and f double prime. Now, the main thing to keep in mind is when it's an indefinite integral, so when you don't have limits, you're asking what equation is the antiderivative or undoes the derivative. So if you do an indefinite integral, you're asking for the equation that is the antiderivative of whatever was inside the integral. That plus c is a constant because it doesn't matter what constant you add or subtract to an equation. If you take the derivative, it's going to go away. So we started by talking about indefinite integrals. When you talk about an indefinite integral, there are no limits, and you're talking about an equation that is just the antiderivative. In a little bit, we'll talk about definite integrals, which do have limits, and you're just talking about the area. Now, within indefinite integrals, you'll have general solutions, where you still have a plus c, and then you have particular solutions, which would give you an initial condition, and you would use that to find the plus c. Your answer is not just the c, it's the whole equation with the number plugged in for c. These are formulas that you're going to need to memorize or put them on your cheat sheet, but at some point you need to memorize them. So the main one that we use is this one. The integral of ax to the n dx is ax to the n plus 1 over n plus 1. And if it's an indefinite integral, you'll have a plus c at the end. So for example, if I want to do this first one, we don't have a quotient rule, so I have to rewrite it as a power rule. So I would say this is the integral of x to the negative 4 dx. So then I would get x to the negative 3 over negative 3 plus c. I'm not going to work all the way through all these problems because they're in a different video. This is just the integral of 1 dx. It's just saying what is the integral of 1. The dx and the integral are just basically grouping symbols. Think about them as parentheses. So what would give you 1 as the derivative? X. And then we need some constant. There's no quotient rule, so make sure you split this one up. You just split it up as 3x cubed over 3x is just x squared. 9x over 3x is just 3. So this is the problem that you would take the integral of. We don't have a quotient rule, so you have to split it up and then take the integral. Particular solutions, again, are just giving you an initial value and using that to find the c value. So if dy dx is 6x squared, that would mean that dy is 6x squared dx. And then if I take the integral on both sides, the integral of dy is just y. The integral of 6x squared would be 6x cubed over 3 plus c. So this is really just 2x cubed plus c. Excuse me. And now it's saying, okay, when x is 1, y is 11. So 11 equals 2 times 1 cubed plus c. So we can solve for our c value. On this problem, it would be 9. That's not the answer. The particular solution is y equals with the c plugged in. So y equals 2x cubed plus 9. If you start with the second derivative, you would do the same idea, you just have to stop twice. So you would take the integral of x squared dx, which would be x cubed over 3 plus c. That's what f prime of x would be. So then use this information to find out what c is for f prime, and then take the integral of x cubed over 3. At this point, you would know what that number was, and take the integral of that, and then plug in these two. Again, this problem is already worked out in a different video, so I'm not going to work it all the way out. But if you started with the second derivative, you would go back to the first derivative, find that constant, and then integrate again and find the second constant. Okay, so then on the second day of Unit 6, we got into definite integrals. So definite integrals have limits, and they are the area underneath a curve. Now really remember, it's the area between the curve and the x-axis, because if my function looks something like this, like a sine function, we're not talking about beneath, like that doesn't make sense because it would go down forever. So we're talking about between the curve and the x-axis. Now, it doesn't have to be enclosed. So you can have a function that's like this, and if I do the integral, I'm still talking about this space, even though this doesn't all the way come back down. In Unit 6, when we talked about the area, we were always using area formulas, and we'll get to that in a second. One thing to note is when you do a definite integral, so a definite integral is going to find the net area. So if it's above the axis, it's positive. If it's below the axis, it's negative. If we want the total shaded area, anything that was below, you need to change to a positive number before adding them together. So for example, the net area for this, which is what the integral from 0 to 2 pi of sine of x dx, that's what the net area would be. And it would be 0. So the integral from 0 to 2 pi would be 0. Now the total shaded area would be this space and then make this positive. So 2 plus 2 would be 4. The easiest way to find total shaded area is to just put absolute value around the equation. So if you are on the calculator portion, the easiest way to find the total shaded area is to just put absolute value and then just do math 9 on your calculator. If you're on the non-calc portion, you're not allowed to do that because you can't just do that in your head. And there's no absolute value formulas on the cheat sheet. So if you're on the non-calculator portion, you would have to figure out where it crosses and separate it as two different integrals. This integral would come out as a negative number, so then you'd have to make it a positive number. So whatever that number was, make it positive and then add it to the other integral. So if you're trying to find total shaded area on the calculator portion, just put absolute value around it. If you're trying to find total shaded area on a non-calculator portion, you're gonna have to do one piece at a time, make them all positive, and then add them together. In Unit 6, we were saying that you can just use area formulas. We had not covered the fundamental theorem of calculus yet, so we would just use area formulas to find out the area underneath the curve. So for example, the integral from -2 to 10 of 3. I'm going to graph the line y equals 3, and then between -2 and 10, I'm going to figure out what the area under the curve is. That's a rectangle, and I would just be doing 12 by 3. So the answer for this one would be 36. All right, -1/2 x plus 4. So if I graph that up at 4, down with a negative slope, I guess it should have been a little bit less steep, so -1/2 x plus 4. And I'm going between -2 and +4. This would end up making a trapezoid. So I would figure out what these two heights are, which are really my base, and then the distance in between them is my height. So this one you'd end up using a trapezoid. Now you can double check your work with Math 9, but you need to know how to do it without a calculator because these types of problems will show up on the non-calculator portion of the AP exam. Now if you have a problem like this, y equals square root of 25 minus x minus 5 squared, it's not obvious what that graph looks like. So you'd want to solve it, so you'd say y squared, square both sides, 25 minus x minus 5 squared, and then add that piece over. So you'd have x minus 5 squared plus y squared equals 25. When you graph this equation is a circle. Since we only have the positive root here, this is a semicircle. And in this case, it's the top half of the semicircle. So you'd graph the top half of a semicircle. So to find the area underneath that, if you need the exact value, Math 9 is not going to help you because Math 9 is going to give you a decimal approximation. So to get the exact value, I'd have to graph it. My radius is 5. My center is at 5, 0. Luckily, it hits perfectly, and when you see this type of problem, it will work out perfectly. So 0 to 10. Half of pi r squared, my radius is 5, so I'd have half pi times 5 squared, so 25 halves pi. Again, all these are worked out back in the 6.2 videos. The other thing that we talk about in 6.2 are the properties that you can use with definite integrals. So the first one is the opposite property. So if you want to flip the limits, just put a negative out front. So if you want to flip the limits, just put a negative out front. If the limits are the same, the answer is 0, because the area between the same number is always 0. If you have a constant, and you can only do this with a constant, you can't do it with a variable, but a constant can be multiplied inside or outside. So, and when you get to u sub, a lot of times you have to multiply by numbers inside or move numbers between and out. So you're allowed to move constants that are multiplied inside or outside. If you have the integral of f of x plus 3 dx, you cannot just pull the 3 out. It's not the additive. It has to be a multiple. So this you cannot do. But if you had 3f of x dx, that's the same as 3 times the integral of f of x dx. Okay, you're allowed to add or subtract integrals just like you can add or subtract derivatives. But there is no product rule and there is no quotient rule for integrals. So if you have a product or a quotient, you have to mess around with it and make it look like one of the formulas that's on your cheat sheet. And the last one is the additivity property, which basically says you can break a definite integral down into 2 definite integrals at whatever number you want. So instead of going from a to c, I can go from a to b and b to c. And you can use whatever number you want as long as it's the same number for both of these. B can be in between a and c or not. It does not matter. Okay. I'm not going to go through these problems. If you want to, you can go back to the whiteboard problems back in Unit 6. But basically, you're using some combination of those theorems. The hard one that I will talk about right here, like I said, you can't just pull the plus 3 out. So you'd separate this as the integral from -1 to 4 of f of x dx plus the integral from -1 to 4 of 3 dx. So when you graph this one, it's going to be a rectangle. So you're going to have to find the area of that rectangle. You can't just add 3 to your answer. This one is going to match what you get when you add those two together. Okay, I'm going to stop here, and then I'll talk about sigma and Riemann notation in a short follow-up video. And again, just go back and watch any of the videos from 6.1 or 6.2 if you want more details. This is just a quick review.